Saxon's Calculus Lesson 19 is about limit of a function. So we just talked about limits in the lesson just a couple ago, and we learned that we normally have a positive and a negative here telling me from which direction I'm pulling the answer, and we only worked out of pictured graphs, not with the actual formulas. So we now need to learn some new skills for what happens when we are given limits and we have things that we can factor or we're working with the equation. So we're going to talk about those rules. Before we get into the rules, they remind you that when you don't have a plus or minus sign, they're basically saying you are checking it from both directions, and it should be a continuity type of graph, no gaps, so there should be no problem with getting the same answer coming from both positive and negative side. So when you are given limit of x yielding 3 from 3, and this is the equation, all you need to do is plug the 3 in for the x. So 6 plus 3 is 9. So the limit of 3, whatever its graph would be 9. So it's just a simple plug in when it's a simple basic equation. Now, when we get over to here, we can't just plug in 2 because we have problems in here. One, the fact that I have squared, which is graphing a parabola type shape, but it's being divided by a denominator shape, a denominator piece that can change the shape. And so if I put in 2, I would get 0 in the denominator, and I know I can't have 0 in denominators, so that tells me that there's some sort of asymptote, or I can't do that kind of picture in the graph. So what we're going to do when you find equations is you're going to try to simplify them as much as possible. So let's factor this x squared minus 4 into x, and then the 4 splitting into 2 and 2. There's no middle term, so I know that one sign should be positive, one should be negative to eliminate the middle term, and then always double check. Positive times negative is positive. Yep, that's an acceptable factor. And then I have the x minus 2 unit down below, which can cancel off with this one. Great, now I'm down to something simple. So 2 plugged in, 2 plus 2 gives a 4. 4 is the limit for this one. Now, example 2. Find the limit x yield 3 with x squared plus 2x over x plus 1. And again, I said we want to try to factor if we can to see if we can eliminate anything. But the only thing I could factor out would be an x, and that would leave me x plus 2. That does not cancel with an x plus 1, so I'm kind of stuck. I can't factor this. So since I can't simplify it in any way, then I just need to plug in my 3. 3 squared is 9. 2 times 3 is 6. 3 plus 1 is 4. So 15 over 4 is that limit. Example 3. Find the limit x to 3 with x squared plus 6x over x minus 3. Again, I can factor an x out. That would leave me with an x plus 6 over this x minus 3. I don't see anything I can cancel, and I still have a problem because if I throw 3 in, my denominator has an issue. See here, it didn't matter, it didn't have an issue, but I can't end up with 0. So when this is the case, I can't factor it, I can't simplify it, and when I plug it in, I have a problem, then I do not have a limit. So you can just say in this one, no limit. Sometimes I do like the null answer, but just need, in some way you need to indicate you can't find a limit. Example 4, limit x to t minus 2 over t squared plus 4. Again, I need to see if I could factor and simplify. Now t plus 4, I don't have a middle term, but I don't have a minus, and I know that that's not going to factor. So then I'm stuck. I can't simplify anything. I'm just going to have to plug in my 2 and see if it works. 2 minus 2 gives me 0 in the numerator. Well, it doesn't matter what my denominator is as long as it's not 0. 4 plus 4, no, it's an 8. So 0 divided by 8 is 0. So the limit is 0. Example 5. Find the limit s from -1 And then the equation 2s squared plus 5s plus 3 over s plus 1. Now, I know I have a problem. If I try to plug in -1, I end up with a 0 in the bottom, so I'm going to have to try to factor this numerator. And this is one of the more tricky factors because it was a 2s squared, so 2s goes in one spot, s goes in the other. Whatever I put here multiplies with 2 before creating the middle term. Thankfully, 3 is the only thing I have, and so if I put 3 here, that's going to be 3 with the 2. Oh, that could give me a 5. Or if I put 3 here, that's 6 and 1. Oh, that could still give me a 5. I'm not sure which way unless I play with it. Since my spacing is tight here, I'm just going to use the book, the 1 and the 3. And so this is 2, this is 3. 3 is the larger of those. 5 is positive, therefore 3 must be positive. And how do I go from 3 to 5? I add 2 more from that multiply. And then we have our s plus 1. The other clue here that I could have used was hoping that I would cancel with the denominator, so try the plus 1. It crosses off, so now I don't have to worry about that denominator issue. So -1 plugs in, -2 plus 3 is 1. 1 is the limit. I don't really want to keep cramming them on there. Example 6, limit x2, and then it gives me x cubed minus 8 over x minus 2. Okay, when I plug in a 2, I get a 0. I know I have a problem. Need to factor if I possibly can. And I see that this x cubed is, if I could make this with a cubed, that's the perfect cube factoring. And I can, because 8 can be written as 2 cubed. 2 times 2 is 4 times 2 is 8. This being the case, then the factoring is the factoring for perfect cubes, which hopefully you recall, pull one thing off of each piece, x minus 2. The leftovers from the x cubed is x squared. There's a middle term, which I'm going to ignore. The last term and the first term are always positive, and that's the leftovers from here. So if I used 1 up, pulling it out, that's 2 squared at 4. And the middle term is multiply these two together and change the sign. So plus 2x. Now, can I factor x squared plus 2x plus 4? Not that's jumping to mind. And then I have my x minus 2. So that is going to cancel with this first piece. Now I've cleared that denominator issue, plugging in 2, 4 plus 4 plus 4, 12. 12 is the limit. And finally, example 7, find the limit x 0, 3 plus x squared minus 3 squared over x. Now, I definitely can't use just the 0 in here because I've created a denominator problem. I can make that 3 squared 9. That's easy enough. But this squared, I probably need to, I could write it as 3 plus x, but it doesn't help me cancel the x. So I'm going to distribute out and see what that does. So 3 times 3 is 9. 3 times x is 3x, doubles to 6x for the middle term, and then the x squared, and then my minus 9. Okay, well, 9 minus 9. I can factor an x out. So x factors out, and I'm going to put this in the right order. X plus 6, because x times x is x squared, x times 6 is 6x. All over the x, now they cancel off. I've cleared the denominator problem. 0 plus 6 is 6, so 6 is the limit.